All right, so here's a little review of trigonometry, or a little overview if you've never had it before. Trigonometry deals with right triangles. So if I have a triangle, and it's a right triangle, and I happen to know that this angle here is 30 degrees, and I happen to know that the length of the hypotenuse, let's say, is 10 meters. Okay, so what trigonometry allows you to do, it allows you to find the sides of a right triangle. So if I have this side here, let's call it y, and I have this side here, let's call it x, we define the ratio of this side, y, divided by the hypotenuse to be the sine of the angle. So the sine of 30 degrees, that's the angle, would be y divided by the hypotenuse, which is 10 meters. So if I wanted to know what y was, I could figure out y. That would be 10 times the sine of 30 degrees. We also define the cosine of the angle, so the cosine of 30 degrees, to be the adjacent side, which is x, divided by the hypotenuse, which is 10 meters. So that means that if you wanted to know what x was, you could take 10 meters times the cosine of 30 degrees. And then these you can actually just put in your calculator and evaluate. Your calculator knows the sines and cosines. So I could take 10 times the cosine of 30 degrees, and that is 8.66. So what I found is that x equals 8.66 meters. That is the length of this side of the triangle. Similarly, I could put in 10 times the sine of 30, and that would be 5. And so I know that y, this side of the triangle, is 5 meters. So what trigonometry allows us to do is to figure out the components or the sides of a right triangle, okay? And you'll spend a lot more time in trigonometry and in Algebra 2 and in geometry, and you touch on it in Algebra 1. Learning about sines and cosines, and if we had more time, we would definitely spend more time on it here. But for us, the implication for physics is as follows. If you have a projectile, and the projectile is launched at some angle, so let's say the projectile is launched at some angle theta. And we want to know how, and let's say it's launched with velocity v0. That's the initial velocity of the projectile. This projectile would actually go up, 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 over, 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 and back down, right? But what we want to know is how fast is it moving initially? So here's what we're going to do. We're going to think about this velocity as having two components. When it's launched at an angle, it is moving horizontally and it is moving vertically. This would be the velocity in the x direction initial, and this would be the velocity in the y direction initial. And to find those, we're going to use trigonometry. So to find the velocity in the y direction initial, we have to take the initial velocity, v0, times the sine of the launch angle. To find the velocity in the x direction initially, we're going to take v0 times the cosine of the launch angle. Okay? So it wouldn't hurt to put those two equations in your toolbox because they are super important. It'd be nice if we could spend more time on trig and figure out why exactly that is, but we're just got to go with what we got because we're on a compressed schedule. So put those two in your toolbox. If you have a projectile launched at v0 meters per second at an angle of theta, this is how you find the velocity in the y direction. So let me go ahead and pause the video if you want. Let me show you how that actually works in practice. Let's say we launch a projectile, and the initial velocity of the projectile is 48 meters per second, and it is launched at an angle of 42 degrees. Okay? This is the launch velocity, 48. This is the angle. So if we want to know what is the velocity of the projectile in the x direction at the beginning of the problem, we are going to take the launch velocity times the cosine of the angle. That means we're going to take 48 meters per second, that's the launch velocity, times the cosine of 42 degrees. So we can put that in our calculator pretty easily. We are going to take 48 times the cosine of 42 degrees, and that should be 35.7 meters per second. Okay? Now, go ahead and try this and make sure you get that, because if you don't get that, your calculator might be in the wrong mode. If you have a graphing calculator like mine, you can go to mode, and there's two ways to measure angles. One's radians, like that, and that's the default. And the other one is over here, degrees, and that's what we want to be in. So you want to make sure you're in degrees mode. So go ahead and try this calculation, make sure you get 35, and if you don't, we need to get your calculator in the right mode. So that tells us that the velocity initial in the x direction is 35.7 meters per second. That's how fast it's going over when it's launched. We can also find the velocity in the y direction initial. That equals the initial velocity times the sine of the angle. So I'm just using up here, velocity in the y direction initial equals v0 times the sine of the angle. That means we take 48 meters per second, that's the launch velocity, times the sine of 42 degrees. And we put that in our calculator. So 48 times the sine of 42 degrees is 32.1. 32.1 meters per second. So what we've found are the initial velocities of the projectile vertically, that's in the y direction, and horizontally, that's in the x direction. Okay? So that's all the trig we're going to use. So go ahead and write this down so you can use it in your toolbox, and then there's an example of how to use it. And then you're going to practice solving some problems with that.